to summarize chapter 9, let me go to the summary slide. Again, these 3 slides will summarize the whole chapter for us, specifically this slide. In this slide, it says that hypothesis testing is a framework for testing the claims about the population parameter using the information from the sample. We begin with the null and alternative hypothesis H0, H1. Then we formulate H0, H1, choose the level of significance. Then we compute the test statistic. How do we select the test statistic? Go to slide number 31. Selection of test statistic depends upon what is the parameter you are interested in, whether sigma is known or unknown, whether sample size is large or small. For the selection of test statistic, come back to this slide. After selection of test statistic, we decide based on either rejection region approach, or we decide based on p-value approach, or we decide based on confidence interval approach. To have the p-value expression, rejection region expression, go back to slide number 32. This will give you everything about the rejection region. And that's it. A few concepts that we only discussed at the beginning of this chapter is that in real life, you have a 2x2 table to explain the situation in terms of hypothesis testing. Here is that 2x2 table. One of the situations is your H0 is actually true. And the other is that it is actually false. You will be under one of these situations. H0 will be either actually true or it will be actually false. And then there are 2 situations what you will decide. You will either reject H0 or you will fail to reject H0. So either you will reject H0 or you will fail to reject H0. This is your decision. So this gives you a 2x2 table. Yes, with 4 cells. What is the first cell? First cell is that H0 was actually true, but you rejected H. What is that? Reject H0 given H0 was. Is that a correct decision? That H0 was true, but you rejected it. It's an error. What is the type of this error? Alpha is what we call type 1 error. Okay. Then the second cell. H0 was actually false. H0 was criminal. And you did what? You sentenced the criminal. Is that a correct decision? The probability of rejecting H0 given H0 is false. This is called power of the test. How powerful you are to say to a person who's wrong that you are wrong. The person is wrong, and you have the courage to say that you are wrong. This is called power of the test. The third cell. H0 is was actually true, but you did what? Is it a correct decision? It is a correct decision. And this is actually 1 minus alpha. And the last cell is what? The person is a criminal, but you don't have the courage to say that the person is a criminal. This is again an error, which is called type 2 error. In exams, sometimes they give you a question about the computation of one of these two errors. For that one, you only need two things. Number one, you need to remember what is the expression of probability expression of that type of error. And number two, you need the knowledge from chapter 2 and 4, 2 and 4, mainly 4, normal distribution knowledge. Again, to solve any question, and sometimes, only sometimes, you will see a question in final exam from this concept. But if you encounter a question from this concept, the only thing you need to know is you need to know what is the probability expression against that error, and you need some knowledge from chapter 4 about solving a question from the normal distribution. That's it. That's all you need. Let me show you how. Now we start the problems. Calculators. Keep the calculators in your hands. Read this question. The question says that a consumer product company is formulating a new shampoo and it is interested in the foam height in millimeters, how high the foam is. Foam height is approximately normally distributed and has a standard deviation of 20. Now, from last 3 classes, I have been giving you hints how to determine if this standard deviation is population standard deviation or sample standard deviation. Read the statement and judge if it is sample or population standard deviation. How? It's the same sentence with the distribution, and distribution is population. Distribution is population. Data is sample. So this is population standard deviation sigma. The company wishes to test mu equals 175 against mu greater than 175. One important point. All of you look at the screen. Very, very important point. Otherwise, you will suffer in final exam. If in final exam you see something like this, because in lectures we use a different notation. If in exam you see something like this, this is equivalent to this. The testing procedure does not depend upon the sign of H naught. You have seen it repeatedly that the testing procedure depends upon the sign of H1. So in exam, if you see a question that test mu equals 175 against less than 175, this is actually this question. Remember this one. The sign of H naught is never important to us. Never important to us. It's the sign of H1 which is important to us. So that question is actually a lower-sided hypothesis, one-sided hypothesis, not two-sided. You will not decide about one-sided or two-sided based on H naught. You will decide it based on H1. Remember this point. In the slides, wherever you see this kind in exam, either they will specify the testing hypothesis using this notation. Most of the times they don't give notation, they give statement in the question. You have to make notation. In some questions, they do give you the notation. And when they do give you the notation, that thing is actually equal to this one, or sometimes the other way around. This is H1. This is equivalent to this, what we did in the slides. Okay, so remember this point. Throughout chapter 9, 11, and 12, the sign of H naught will never be important for you. It will be the sign of H1 that will decide all the things. Now let's get back to the question. Again, you can see from the question, it's an upper-sided H1. H1 is more than 175. So this is what you are interested in testing. Using the results for the sample size. What is the sample size? And what is the critical region, rejection region? You will reject H naught if your sample mean is greater than 185. What are they asking you to find? Alpha. Again, you need only two things. Number one, you need to learn how to write a probability expression for the definition of alpha. What is alpha? It is the probability of type 1 error. Type 1 error is an error where H naught was H naught was true, but you rejected it. Correct? Now look at the question. The question is giving you the rule for rejecting. When will you reject H naught? Look at the question. What is the rejection region or critical region? You will reject if X bar is above. And what is H naught? That mu is 175. Correct? Now, how do we solve a question of probability related to X bar? Go to chapter 7. How do we solve a question about X bar? Convert it to Z. With what formula? And the value of mu that you will use in conversion is this value of mu, conditional value of mu, given value of mu. So let's transform it to Z. This is the probability X bar minus mu divided by sigma over root of n 185 minus, I will put the condition in now. Is it 185? Yeah. 175 over, what is the sigma? What is n? And that's it. You already put the condition, so no need to write the condition now. You already applied that condition of mu being 175. Do we know how to solve this question now? It's a simple question from chapter 4 now. So this is probability of Z more than calculators. It's 10 divided by 20, which is 0.5, square root of 10, 1.58. It will not be exact, right? Yeah, so I will write approximate sign. Again, now you are expert in solving this question. Can you get this answer directly from the Z table? The answer is no. So this will be 1 minus. And this will be, what's the final answer? 1 minus. Anyone has the Z table? Okay, let me go to the Z table. 1.58. Area below 1.58. Better not to do it. It will confuse you. It is correct, but it will confuse you. 1.58. 5, 0, 1, 2, 3, 4, 5, 6, 7, 8. This value. 94295. 94295. 0.005. So it is 5.705% alpha. With that rule, you were actually working with almost 5.71% alpha. Second question, same statement, but the question says, what is the probability of type 2 error if the true mean is 185? Now your H1 is true. H1 is true. Your true mean is 185. What is the expression for beta? Again, two things. You need to remember the expression, probability expression for beta, and you need some knowledge from chapter 7. What is the expression for beta? When do you fail to reject H naught? Look at the statement. Is the rejection region given to you? Is the rejection region given to you? Yes or no? The rejection region. Yes. So the complement of this region will be the acceptance region. So if X bar is more than 185, you will reject. When will you not reject? Given, what is the situation given to you? H naught is false. What is the value of mu that is given to you? This value of mu belongs to H1 actually. H1 mu is actually more than 175, and they gave you the exact value of mu, which is more than 175. It is 185. Yes. Yeah, it is 185. Because we are under H1 now, not under H naught. It's beta. H naught is false. Mu is not 175. It is 185. Can you solve this expression? Very simple, chapter 7. This is probability of x bar minus mu sigma over root of n less than or greater than, less than equal to 185 minus 185 over 10, not 10, 20 over square root of 10. And this is equal to probability of z less than 0. You need to go to the table for this. The answer is 0.5. So the probability of type 2 error here is 50% of the times you will fail to make a correct decision here. You will fail to reject H naught even when H naught is false. A technical point. Again, it's a similar question. You have to find beta when the actual mean is not 185, it is 195. So let us see how the type 2 error changes if we change the value of mu. Here, beta will be probability of x bar less than equal to 185 given H naught is false. That means mu is 195. So this will be probability of x bar minus mu over sigma over root of n less than equal to 185 minus 195 over 20 over square root of 10, which is probability of z less than minus 1.58, and this is 0.94295. Not 9, this is less than 0.05. 0.05 0.05705. Now, this gives you some information. Okay, this gives you some information. The situation. Let me say mu. When it was 185, you are testing H naught, that mu is greater than or equal to 175 versus H1, that mu is it less than or greater than? What were you testing? Greater than 175 against less than equal to. When mu was 185, beta was 0.5. You remember? Part 2. When mu is 195, beta is 0.05705. The probability of type 2 error decreased. Can you make a logic out of it? Why it decreased and how it decreased logically? Let me give you an example. The example is, I have to test the hypothesis that a person from this room is wearing white clothes against H1, that the person is not wearing white clothes. Okay. H naught is that the person is wearing white clothes. H1 is the person is not wearing white clothes. Okay. Anyone who's wearing off-white? Close to white. Okay. Let's say I select the sample and the sample is Jasir. When I see visually, what are the chances that I will make the error? Jasir is not wearing white, right? H naught is the person is wearing white clothes. And H1 is the person is not wearing white clothes. If my sample information comes from Jasir, Jasir is not wearing white clothes, what are the chances that I will make error? Because the color is very close to white, right? The chances I will make error are very high because H1 is very close to H naught. This 185 is very close to 175. H1 is very close to H naught. But what if I select name? Rashid. if I select Rashid and say Rashid is wearing white clothes, what are the chances of making error in case of Rashid? Almost 0% chances, because H1 is very far from H0 and it's very clear. So 195 is very far from 175, and you can clearly see that it is far, and the chances that you will make error are much lower. Similarly, if H1 is 205, the type 2 error probability will be even lower. If H1 is 176, very high, because of white and white, very difficult to differentiate. Very difficult to differentiate. So if H1 is in the neighborhood of H0, the type 2 error will be very high. The power will be very low. What is power? 1 minus type 2 error. The power will be very low. And if H0 is far, the type 2 error will be low, power will be high. Power is 1 minus beta. So in that case, power is 50%. In this case, power is 95%. Let's move on to another question from proportion. I will just write the expression and not solve completely. You can solve it using your knowledge from chapters 7 and 8. The proportion of residents in Phoenix, favoring the building of tall roads to complete the freeway system, is believed to be 0.2. If a random sample of 100 residents show that less than that 10% or fewer favor this proposal, we conclude that P is less than 0.2. So you are actually testing H0, that P is 0.2 versus H1, that P is less than 0.2. Okay, and what is the rejection region? You will reject H0 if the sample proportion is less than or equal to less than equal to 10%, 0.1. If the proportion from the sample, you have a random sample of 100 residents, and if the sample proportion of people favoring blah, blah, blah is less than 10%, you will conclude that H1 is true. That means you will reject H2. This is the decision rule. What are they asking us to find? Find the probability of type 1 error, alpha, which is probability of rejecting H0 given H0 is true. When will you reject H0? And under H0, what is the value of P? How do we solve any question about P hat? We have the formula P hat minus P naught, 1 minus P naught over square root of n, convert it to Z. So simply convert it to Z using this value of P naught 0.2. So this will be probability of Z less than equal to 0.1 minus 0.2 over 0.2 into 0.8 over 100 square root, get the value of Z, go to the table, get the probability, and type 1 error. Any question? Take 35 seconds and digest it. Yes. Lot? Not lot. An exam may be 1 maximum. If not 0. I estimate 0. But you never know, because the topic belongs to the syllabus. The topic belongs to the syllabus. So we are supposed to know it. Yes. Yeah, find alpha and take 1 minus. What is the significance level? What is alpha? 1 minus alpha? Significance level. What is alpha? No, sorry. Alpha is significance level. 1 minus alpha is confidence level. Power. Beta is type 2 error. 1 minus beta is power. So they can ask you a question about any of those 4 cells of the table. The table has 4 cells. Alpha 1 minus alpha, beta 1 minus beta. So they can ask you a question about any of the four. For any of the four, you need to compute alpha and beta. From alpha and beta, you can easily find 1 minus alpha and 1 minus beta. Let's solve another one here. The same question, but here they are asking you to find the probability of type 2 error if the true value of P is 0.08. So what is the expression for beta? Again, we need to know the expression for beta and some knowledge from chapter 4 and 7. Beta is probability of, is it? Failing to reject H0. Given H0 is false. When do you fail to reject H0? The question says you will reject H0 if P hat is less than or equal to 10%. So when will you fail to reject H0? When P hat is not less than or equal to 10%, right? The complement of this statement I took. I took the complement. This is the rejection region. The statement gives you the rejection region. I took the complement of the rejection region, failing to reject H0. Given what situation is given to us, H0 is false. What is the false value of P which is given to us? It is less than 20%, but what specific value is given to us? 8% is given to us. So again, transform it to Z. This is probability P hat minus P naught into 1 minus P naught over N square root greater than 0.1 minus 0.08, 0.08, 0.92 over 100 square root. And this is probability of Z more than calculators. Let me judge my mental math. Yes. Yes. See? And you will go to the Z table. I prepared the slides last night. I remember it was 0.74. You go to the Z table and get the lower tail area and then 1 minus. Look at this question. For this question, you need to solve the previous question. What is it asking you? Power. Power is what? So you get beta from the previous question, this one. I don't know what it is. You get it from there and plug it into the power. 1 minus beta will be the power. You don't use you use it here if they ask you for alpha. P equals 0.2 under H0, but it is not 0.2 under H1. If they ask you for alpha, that means you are under H0. Alpha is actually given H0 is true, so you are under H0. For beta, of course, you are not under H0. By definition of the beta, you are not under H0. You are under H1. So you use a value of P which is under H1. H1 says that P is less than 20%. Then for computation, they will give you a specific value of P which is less than 20%. And in this question, that specific value given to us is 8%. We cannot solve a question general for any value of P less than 20%. It has to be specific. Now in exam, if I ask you, I give you that the type, can someone give me the final answer of this one? More than 0.74. Okay, I will use the symmetry. Zero, 1, 2, 3, 4, 22965. 0.22965. If I change the question from 8% to 15%, what happens to probability of type 2 error? Will it increase or decrease? Instead of P equals 0.08, I change to P equals 0.15. Decrease or increase? I'm getting close to H0. H0 is that P is 20%. I go close to H0. So the probability of making error will increase or decrease? It will increase. What if I change it to 0.19, very close to H naught? What will happen? Increase very high. The probability of type 2 error will be very high. To differentiate that P is 0.2 or 0.19, it will be very tough for the sample to differentiate. So the sample will make error with the very high probability. The difference between 8% and 20% is huge. So 80% of the time, your sample was able to find that difference. Only 20% of the times it made the error, type 2 error. What if I'm testing P is 0.01 against 0.2? Big difference. So almost 99% of the times you will have the correct decision. Only maybe 1% or less than 1% of the times you will have the error. So if your H1 is in the neighborhood of H naught, beta will be high. If you are far from H naught, beta will be low. Now let us move on towards the objective of this class. Problem solving. I'll be very quick now. This is the term 241. 6 questions from chapter 9. A semiconductor manufacturer collects data from a new tool and conducts a hypothesis test with the null hypothesis that the critical dimension. What is the null hypothesis? Is it about mean or proportion? That's the first question you will ask yourself when you enter chapter 9. Is the question about mean or proportion? Mean. What is the null hypothesis? Mean is equal, less than equal, greater than equal. Based on the data, the decision is to not reject the null hypothesis. What is your conclusion? This is given in the question. What will be your conclusion? Not to reject H naught. What do we mean by not rejecting H naught? Fail to reject H naught. That means you will go with H naught, right? Now, what are the two options that correspond to H naught? This one and this one. These are corresponding to H naught. Which one is true? A. Why not B? You never 100% sure that it is exactly 100. Maybe it is 100.00007. Right? So you will say it is not significantly different from 100. You will never say it is 100. That's why in every hypothesis testing question, you will never use the terminology that we accept H naught. What terminology do you use? We fail to reject H naught. You never say we accept H naught. Accepting means that mean is exactly 100, 0.0000000000000, which is almost not possible. So option A here is the correct one. I'm not pretty sure if I randomized the options before coming or not. Output from the software package gave you a one sample Z test. Again, you see most of the question in exam, they are using equal versus greater. But what we used in slides, it's like this. Less than equal against greater, which is the same thing. Okay. So what's given to you? H naught, H1 is given to you. What is this? Sample standard deviation or population standard deviation? Sample or population? Assumed. Why would you have to assume something about the sample? Sample is in your hand. You don't have to assume anything about sample. You know everything about sample. You assume about something unknown. Population, it is sigma. Another indication why it is sigma. Which test are they using? Z test. And Z test is used when sigma is known. So that known value is 0.75. What is the p-value? So it's a simple calculation question. How do you compute the value of Z? What is the X bar? From the output. What is the value of mu that you are testing in H naught? What is sigma? Over what is N? Once you get the value of Z, calculators will tell me, then you have to find the p-value. Again, the p-value expression comes from the sign of H1. What is the sign of H1? What is the sign of H1? Go and check where is H naught H1. What is the sign of H1? Why do you think that greater than is H1 and not the first one is H1? Equal sign is always with H naught. The one without equal sign is H1. So H1 is greater than, p-value expression will be greater than. So what is the value of Z naught we got? 1 point. So the probability of Z more than 1.3. So go to the Z table and look for this probability. Yes.
Why the first line of the outputs, he says one sample Z.
Because chapter 10 is about two samples Z that we do not teach. There are two variables, X1 and X2. There is a two sample version of Z also. It has nothing to do with one-sided.
Sample standard deviation because of
No. There is another version of Z test which is for two samples. For example, you are interested in comparing the average of two sections. Mu1 is equal to mu2 against mu1 is not equal to mu2. So you will get the sample from both sections and test if the means are equal. That's not in the syllabus, two populations. An engineer who is studying the tensile strength approximately normal distributed with sigma equals this, a random sample of 12 specimen. What is 12? N gave me a sample mean of 23800. Test the hypothesis that the mean, what are we supposed to test? The mean strength is 24150. Use alpha 5%. Which one of the statements is not true? First, let's formulate H naught H1. Take the statement and write the statement in terms of notation. What is the statement in terms of notation? Here is the statement. You enter chapter 9, decide is it about mu or P? Statement is about mu or P? Mu. Then what is the statement? Equal. What is the opposite? Which one contains equal? Okay, you formulated H naught H1. Then for this H naught H1, when will you reject H naught? Again, go to the table of slide number 32. Reject H naught if it's a two-sided H1. If Z alpha by 2 against 5% will be 1.96. We know that. So if absolute value of Z naught is more than 1.96. Now, 4 of these statements are true. One of them is wrong. Which one is wrong? We reject the null hypothesis if Z naught is more than 1.96. Is it the same as this statement? No. So it seems like I forgot to randomize before coming. Is this statement same as the rejection region? Yes, this is about p-value. I will compute the p-value. Is this statement same as the rejection region? Yes. Compute the z value. What will be the z value? Let us compute the z value and p-value to confirm option number C and E. To compute the z value, let us plug in everything. What is X bar given to us? Minus what is mu under H naught? What is sigma? What is N? 12. Calculators. Of course, it is true, so it will be minus 2.92. Is it? Yes. So finally, p-value, it will be 2 times probability of z more than z naught absolute. This is 2 times probability of z more than, what is absolute of minus 2.92? 2.92. So this is 2 times 1 minus probability of z less than 2.92. And this p-value will probably come out to be 0.0035. Once you get the value from the table and plug in, it will be around 0.0035. So this will enable you to identify that all the options except for A, they are true. The only option which is not true is A. This two-sided condition cannot be expressed as a one-sided condition. Okay.